Determining the number of light fixtures permissible on a 20 amp circuit involves understanding wattage limitations and adhering to electrical codes. A 20 amp circuit operating at 120 volts has a maximum capacity of 2400 watts. This is derived from the formula amps times volts equals watts, so 20 amps multiplied by 120 volts equals 2400 watts. However, it's crucial to apply an 80% rule to prevent overloading the circuit. This rule limits the continuous load to 80% of the circuit's capacity. To calculate the maximum continuous load, multiply the circuit's total capacity by 0.8. In this case, 2400 watts multiplied by 0.8 equals 1920 watts. This means that the total wattage of all light fixtures on the 20 amp circuit should not exceed 1920 watts during continuous use. To determine the number of light fixtures you can safely connect, divide the maximum continuous load by the wattage of each fixture. For example, if each light fixture consumes 60 watts, you can connect 1920 watts divided by 60 watts per fixture, which equals 32 fixtures. This calculation provides a theoretical maximum. Factors such as the type of light fixture, the presence of other loads on the circuit, and local electrical codes can influence the actual number. Different types of light fixtures, such as incandescent, fluorescent, and light-emitting diode or LED, have varying wattage requirements. Incandescent bulbs typically consume more power than fluorescent or light-emitting diode bulbs. Therefore, you can connect more light-emitting diode fixtures than incandescent fixtures in the same circuit. Consider the inrush current, which is the instantaneous current drawn when a light fixture is first turned on. Some fixtures, particularly those with electronic ballasts, may have a high inrush current that can briefly exceed the circuit's capacity. This can cause nuisance tripping of the circuit breaker. When calculating the number of fixtures, account for the cumulative inrush current to prevent overloading the circuit. It's essential to consider any other devices or appliances that share the same 20 amp circuit. Adding the wattage of all devices connected to the circuit ensures that the total load does not exceed the 1920 watt limit. For example, if you have a television that consumes 100 watts and a computer that consumes 200 watts, the total load from these devices is 300 watts. Subtract this from the maximum continuous load of 1920 watts, leaving 1620 watts for light fixtures. You would then divide 1620 watts by the wattage of each light fixture to determine the number you can safely connect. Local electrical codes and the National Electrical Code or NEC provide specific guidelines for electrical installations. These codes aim to ensure safety and prevent electrical hazards. Consult the relevant sections of the NEC or local codes for requirements related to circuit loading, wiring methods, and overcurrent protection. These codes may specify limitations on the number of fixtures per circuit based on factors such as wire gauge, voltage drop, and the type of occupancy. Voltage drop refers to the decrease in voltage along the length of a conductor due to its resistance. Excessive voltage drop can cause lights to dim, appliances to malfunction, and equipment to overheat. To minimize voltage drop, use appropriately sized conductors for the circuit. The NEC provides tables that specify the minimum conductor size based on the circuit's amperage and length. When calculating the number of fixtures, consider the voltage drop to ensure that the voltage at the last fixture is within acceptable limits. The type of occupancy, such as residential, commercial, or industrial, can also affect the number of fixtures allowed on a circuit. Commercial and industrial occupancies often have more stringent requirements due to the higher electrical loads and potential for increased risk. Consult the NEC or local codes for specific requirements based on the type of occupancy. Proper wiring methods are essential for safe electrical installations. Use appropriate wiring materials such as non-metallic sheet cable or conduit, and follow proper installation techniques. Ensure that all connections are secure and that the wiring is protected from physical damage. Incorrect wiring can lead to electrical shorts, fires, and other hazards. Overcurrent protection devices such as circuit breakers and fuses are designed to protect circuits from overload and short circuits. These devices interrupt the flow of current when it exceeds the circuit's capacity, preventing damage to wiring and equipment. Ensure that the circuit breaker or fuse is properly sized for the circuit's amperage. A 20 amp circuit should have a 20 amp circuit breaker or fuse. Never use a higher amperage over current protection device, as this can allow the circuit to become overloaded and create a fire hazard. When connecting light fixtures to a circuit, follow the manufacturer's instructions and ensure that all connections are properly made. Use wire connectors that are suitable for the size and type of wire being used. Avoid over-tightening or under-tightening connections, as this can lead to loose connections and electrical problems. Test the circuit after installing the light fixtures to ensure that it is functioning properly. Use a multimeter to measure the voltage and current at the fixtures. Verify that the voltage is within the acceptable range and that the current does not exceed the circuit's capacity. If you encounter any problems, such as flickering lights or trip circuit breakers, investigate the cause and correct it before using the circuit. If you are unsure about any aspect of electrical wiring or calculations, it is always best to consult with a qualified electrician. Electricians have the knowledge, skills, and experience to perform electrical work safely and in compliance with electrical codes. They can assess your specific electrical needs and provide recommendations for the number of fixtures that can be safely connected to a circuit. Attempting electrical work without proper knowledge and training can be dangerous and may violate electrical codes. Remember that electrical codes and regulations can vary depending on the location. Always consult the local authorities or a qualified electrician to ensure that your electrical installations comply with the applicable codes. Regularly inspect your electrical system for any signs of damage or wear. Check for loose connections, frayed wires, and damaged fixtures. Replace any damaged components promptly to prevent electrical hazards. Consider using energy-efficient light fixtures, such as light-emitting diode bulbs, to reduce your energy consumption and lower your electricity bills. Light-emitting diode bulbs consume significantly less power than incandescent bulbs and have a longer lifespan. This can result in significant cost savings over time. Install ground fault circuit interrupter or GFCI protection in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Ground fault circuit interrupters are designed to detect ground faults, which occur when electricity flows through an unintended path, such as through a person. Ground fault circuit interrupters quickly interrupt the flow of electricity, preventing serious injury or death. When working on electrical circuits, always turn off the power at the circuit breaker or fuse box. Use a voltage tester to verify that the power is off before touching any wires or components. This will help prevent electric shock. Wear appropriate personal protective equipment, such as safety glasses and rubber gloves, when working on electrical circuits. This will help protect you from electrical hazards. Do not work on electrical circuits when you are tired or distracted. It is important to be alert and focused when performing electrical work. If you are not comfortable working on electrical circuits, it is best to hire a qualified electrician. Electricians have the training and experience to perform electrical work safely and correctly. By following these guidelines and consulting with a qualified electrician, you can safely and effectively determine the number of light fixtures that can be connected to a 20 amp circuit. Remember that safety should always be your top priority when working with electricity.